Hello, everyone, and welcome back to the channel of Math and Engineering Made Easy. As I mentioned last time, today we are going to show how we graph inequalities and show the solution space. And then next time, we'll finish this part of the course by solving word problems, graphing the inequalities, and finding the solution. So here we have like 6 problems divided into 2 parts. Like the first part, they give you 3 problems and ask you to find where the area bounded by these inequalities is. And then in the last 3, they give you the area and they tell you, oh, what inequalities produce those? Okay, so let's start. In the first part, they give you 3 inequalities. They said x is less than or equal to 4. Less than or equal, as you remember, we draw it as a solid line. If it's just greater than or less than, like this case, we draw it as a dotted line. Also, what you need to remember so that you don't waste time trying to think it over, if the inequality has only x, it means the line is perpendicular, parallel to the y. And if it has only y, it means it's horizontal, parallel to the x. So the first one says x is less than or equal to 4. So you locate x equals 4, and then you draw a vertical line, and you say the area satisfying that is to the left. Why to the left? Think. It's to the left because it says it's less than, right? Less than is to the left, but it's a solid line because it's less than or equal. So here is my line. And then I can do a very small arrow to the left. So I know later, when I did the first inequality, was it to the left or to the right? So I have to go back and read, oh, to the left. No, just a small arrow, very small arrow here shows you that, oh, everything to the left of this line is okay. And then we say, no, not necessarily, because the second one said y is greater than or equal to -1. Here, notice y meaning it's horizontal. Y is -1, it's here. It says -1. And it's greater than or equal. So I'm going to draw another solid line here. And I can do a small arrow showing up because it's greater than that. And here you can, it's usually better to write, you say, this is x less than or equal to 4, and this is y is greater than or equal to -1. The last one is y equals x, less than or equal, but we draw y equals x. We know that it's a line that makes 45 degrees with the horizontal, meaning 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. It's very simple to draw. That's the easiest line to draw. And the third one also is y is greater than or equal to x. Oh, I'm sorry, y is less than or equal to x. The y is this, the vertical, is less than the horizontal, so I have to go down. And all 3 lines are solid, okay? Here, y is less than x. So if x is for example, x is 2, y is either, oh, I'm sorry, I thought this was the origin. Oh my God, I messed it up. I said it's so easy to draw, but because I'm drawing with the, okay, guys, should cancel this and start a new one, I think. Oh my God, how did I see that this wasn't the origin? No. Okay, sorry guys, this doesn't erase properly, but here is the y. equals x. And again, many of you must have seen that while I was drawing and you were shouting to me, no, that's not correct. Okay. This is, and the arrow should be going down because y is less than x. So now below this line, above that line, and to the left of this line. This is the area that we should shade. So any point here inside of this triangle satisfies all three equations. For example, if I pick this point, x is 1, y is 0. X is 1 meaning it's less than 4. Y is 0 meaning it's greater than or equal to negative 1. And y 0 is less than 1. So I'm right. Any point inside as well as on the line, on these three lines, is inside my solution space. So I write S in this shaded area, meaning the solution, any point here can be used as a solution to the system. I'm so sorry about that. I have to be more careful. Now, when we move to the second one, x vertical is greater than negative 1. Here is negative 1, but it's not greater than or equal. So I have to draw a dotted line or dashed line, not a solid line. X, this one, x equals negative 1, right? But x is greater than that, meaning it's to the right of this dotted line, meaning a point on this line doesn't satisfy the equation because a point on this line is x equals negative 1, but negative 1 is not greater than negative 1. That's slightly to the right of that is okay. Okay. Y is greater than or equal to 0, meaning above the x-axis. I don't need to draw anything. I can simply say this is y equals 0, and anything above that would be y greater than or equal to 0. And then x plus y equals 3. Many people have their mindset that if I have a straight line, I have to write it y equals mx plus b. No, you don't. As I told you before, divide the right-hand side by the coefficients and you get the x-intercept as well as the y-intercept. Both of these are 1, 1x plus 1y, right? So 3 over 1 is 3, that's the x-intercept. 3 over 1 is 3, that's the y-intercept. I join these two lines and I have, oops. This is 3, this is 3, so why it's not getting, okay, now it's better. This is a solid line again. And this line is x plus y equals 3. But I want x plus y to be less than 3, so I am below this line. So to the right of this line, above that line, and below this line, so it's this triangle, not included the dotted part. So you shade this, right? And this is my solution space. Last one. 2x plus 3y is less than 6. So I draw 2x plus 3y less than 6, equals 6 as a dotted line. Again, how do I find the x-intercept? I divide 6 by 2, I get 3. How do I get the y-intercept? 6 divided by 3 is 2, so here is 2. Much faster than to do y equals mx plus b and try to find the y-intercept and then the slope and then count how many I go side. No, just divide. If it's divisible, because sometimes you don't have this luxury. Oh, I'm sorry. This is again goofed. This is dotted. Don't draw it solid. If it's solid, it's wrong. Better erasers here. Not this one, definitely. Daughter who keeps playing with my stuff. I have to make that a restricted area. Nobody comes to my study. I can't find it. So maybe I'll use a different color and make it dotted so or dashed so you know this is not a solid line. The previous problems were all solid lines. So okay, so this is 2x plus 3y less than, so this is basically 2x plus 3y equals 6. And then if they are less than 6, I will draw an arrow going down. Y is less than or equal to x plus 2. So that's a solid line, but it's already y equals mx plus b. The slope is 1 and the y-intercept is 2. So here is the y-intercept and the slope is 1, meaning I move 1, 1, or 1, 1, or 2, 2, or 2, 2, and it's easy. It's a solid line this time, so I can draw a solid line like that. This is y equals x plus 2, and I go below it because y is less than that. And finally, I go to y greater than or equal to -1. That's a horizontal line, and it's dashed. Y equals -1. It tells you greater, so the y is above it. And again, sometimes if the line doesn't pass through the origin, the easiest way to check and to say, let's look at this dotted line, okay? And I say, is it above or below? I don't know. So the easiest thing is to pick the origin and say, if x is 0 and y is 0, the left-hand side is 0, and 0 is less than 6, it's correct. So I'm below that. If this number doesn't satisfy it, I would say no, so I am above. Let's do it for this one. Y is less than x plus 2. So I make it 0 and 0. 0 equals or less, it's less than. So 0 is less than 0 plus 2. 0 is less than 2. Yes, it is. So the origin is also part of this line. Y equals -1 is here, and y greater than -1. Okay, so if x is 0, we don't have x. If y is 0, is 0 greater than a negative number? Yes, it is. So the 0 is in the region. And now I have to below this line, above this line, below that line, it's this triangle. But this side of the triangle is not, and that side are not parts of the solution. The solution is this triangle without these two lines. I have to be slightly below this line or slightly above that line to have a solution space here. And that's how we plot them. It's exactly like plotting the equation, not the inequalities, and then figure out, is it to the right or to the left, above or below? And usually it's very easy. Now, they tell you, oh, now we are giving you a solution space. We want you to find what were the inequalities. We have 3 inequalities. 2 of them are greater than or less than and equal, and 1 of them is strictly greater than or less than. Let's see. This is vertical, so it's x. -2. to the right or on the line because it's a solid line, so greater than or equal. This one horizontal, so it's y. Solid, so there is equal. This is -2, also -2. Above it, meaning greater than or equal. The last one is a straight line, but it's strictly greater than or less than. The equation of this straight line, first of all, the y-intercept is 3, and the slope, I go 1 to the right, 1 down, 1 to the right, 1 down. So m is 1. So y equals mx plus 3. But it's below. So I have to say y is less than x plus 3. It's not equal because that's a dashed line. And it's below. Again, as I said, see if it should be below or above. So make x and y equal 0. 0 is less than 0 plus 3. 0 is less than 3. Yes, it is. So the origin is part of the solution as we see. Let's move to the second one. I have 2 dotted lines and a solid line here, which is y greater than or equal to 0, right? That's the x-axis. What is this one? It passes through the origin, so it doesn't have b. b is 0. And it's moving 1 to the right, 2 up. The slope is 2. So y and 2x plus 0, right? But is it the y is above the 2x or below the 2x? Well, it's below, so it's less than. Notice, I cannot check the origin because the origin doesn't tell me I am here. So you can pick 1 and 0, for example. 1 and 0. If x is 1, you get 2 on the right-hand side. And if y is 0, you get 0 is less than 2. Yes, it is. So it's below this line. How about that line? B. I don't have B. I can extend it, but am I drawing it in the same like proportion or something? Going from 3 to 1, the slope here is negative because it's going down. The change in y is 2, the change of x is 2, so m is -1. But what is the y-intercept? Well, I know that the slope is -1, so if I move 1 to the left and 1 up, I get to this point, so b is 3. So this is y, I'm not going to say equal, I'm going to say y on the left-hand side, -x plus 3 on the right-hand side, and then say, well, if I have a 0 and 0, 0 and 3, yeah, 0 is less than 3, so I'm done. Finally, I have, this is a solid line, vertical meaning x, right? So x and -3. It's to the right of x, so x is greater than, it's solid, so greater than or equal to -3. How about this one? It passes through the origin, so b is 0. But what is the slope? I move 1 to the right, 1 down, 1 to the right, 1 down. So it's -1. Right? Y, -x. And y is below that. So y is less than -x. Oh, I'm sorry, that is, yeah, less than or equal. It's a solid line. And finally, I have this line, this dotted line. B is -3. And the slope is what? I have a point here that I can see and a point there where it crosses. I move 2 to the right, 1 up, so the slope is 1/2. So y on the left-hand side, 1/2 x minus 3 on the right-hand side, and y is above that So y is greater than that. I want to check to see if that makes sense. 0 and 0 is in the region, the good region of this dotted line. 0 is greater than 0 minus 3. 0 is greater than negative 3. Yes, it is. So I'm fine. So now we finish that by finding, either by finding, by graphing the inequalities or by finding the inequalities that resulted in that solution space. And we will need this because in the next session, we are going to read word problems. We are going to translate the English into math and then see what inequalities are there. Does it say greater than? Does it say less than? It's greater than or equal, less than or equal. And then we can easily plot them since we learn how to do it today. Okay? I hope you understood this clearly. If you have any comments, please don't hesitate to let me know and I will respond to you as soon as I can. Otherwise, I wish you all the best and hope to see you soon. Bye.